So this question says, identify the conjugate base and conjugate acid of each of the following. So we're going to identify the conjugate acid and conjugate base of each of these. So the conjugate base is going to be this having lost a proton, and the conjugate acid is going to be this having gained a proton. Said another way, the conjugate base is formed when this acts like an acid. When this acts like an acid, it loses a proton. The conjugate acid is formed when this acts as a base. When this acts as a base, it gains a proton. So here, the conjugate base is where this acts as an acid. So when it loses a proton, we get SO3, and it loses H+. So what's left is 2-. Okay, because it loses a positive charge. In this case, if it acts as an acid, it gains a proton. So we get H2. If it acts as a base, it gains a proton, so we get H2SO3. So again, the conjugate base is formed when this acts like an acid and loses a proton. The conjugate acid is formed when this acts like a base and gains a proton. Remember that it's H+. So if it loses H+, it's now 2-. If it gains H+, it goes from minus to now neutral. Let's look at NH3, ammonia. When ammonia acts as an acid, what you end up with is NH2 with now a minus charge because it loses H+. So now this is minus. When this acts as a base and gains a proton, you get the conjugate acid, which is NH4. It now has one extra proton, and it has the plus charge. H2O. When H2O acts as an acid and we make the conjugate base, we get OH minus. Okay, we don't write that as HO minus, we write it as OH minus. And then when H2O acts as a base and we get the conjugate acid, H3O plus. What about H2PO4 minus? When H2PO4 minus acts as an acid and we get the conjugate base, we get HPO4, now with a 2- charge because it loses H+, so the charge is more negative. And in this case, when it acts as a base and it gains a proton, we get H3PO4, and instead of being minus because it gains H+, it is actually neutral. So this is how we can find the conjugate acid and conjugate base of each of these species.